continue on here. Let's look at this. We have an extreme value. Okay, let's go on. Critical number value. Let the function be defined at C. Okay, what does C represent? Input or output? Input, okay. Again, as you read mathematics, you have to interpret as you go along. Now, I don't know if you've studied a foreign language before. I think I've told you I studied French in college and haven't really practiced it, so I don't know much of it. But I remember that I was at the point where I had to interpret as I listened and as I read, because it wasn't second nature to me. Same thing happens with this. So if you've ever studied a foreign language and you know how it is that you have to interpret as you go along, the same thing happens here. So we're going to interpret. C is an input. Let the function, the output values, be defined at some input C. If the derivative at that point, where the input is C, is 0, okay, so if the derivative is 0, which tells you what the slope of what kind of a tangent line? Horizontal line, okay, or, this is an important or here, or if the function is not differentiable at C. We talked about functions that are non-differentiable. Things that have a sharp turn, like this, would be non-differentiable. And so if it's, and we have also things that actually go up and have a vertical, such as this. So if they're not differentiable, or if the derivative is 0, then C is a critical number of the function. Back on our graph, how many critical numbers do I have here? 3. One corresponding to the minimum, one corresponding to the maximum, one corresponding to this minimum. So I have 3 critical numbers. The critical numbers are input values. What would be the input values? Well, what's the input value at this point? What's the input value at this point? And what's the input value at this point? Okay. So the critical numbers are what we are considering as what makes the derivative 0 or undefined. Relative extrema occur only at critical numbers. We're kind of saying the same thing, aren't we? Didn't we just define the fact that at a maximum or minimum we have what we call a critical number? And now we're saying that relative extrema occur only at critical numbers. So if the function has a relative minimum or maximum at x equals c, then that value C is a critical number. Again, we throw these things into theorems so that later on, if some of you are going into be a math major and you get into Math 101, which is the theory of math, and you do lots of proofs, and your Calc 2 professor and Calc 3 may require you to do algebraic proofs, you need to go back and cite things like this. I know this is true because there's a theorem that says relative extrema occur only at critical numbers. Okay. Well, let's see what we've got here. Find any critical numbers of this function. So if I want to find any critical numbers, what's the first thing I have to do? I could graph it. Analytically, though, what's the first thing I would do? Find the derivative. Did you say that? Yeah. Okay. Find the derivative. Take the derivative. So let's go through and do this derivative. Now here are secant theta and tangent theta. These are trig functions that I'm not asking you to memorize. You could say that f of theta is 2 divided by, and then know that secant is the reciprocal of cosine theta, plus tangent, which is sine theta divided by cosine theta. So we could say this is 2 plus cosine, 2 plus sine theta divided by cosine theta. So I could take the derivative using the quotient rule, going back to the 2 trig functions that you know, or if you happen to know what the derivative of secant theta is, you could use that also. I'm going to give you a couple seconds. I'm working it through the way that I'm thinking most of you are working it, that is, interpreting using sine and cosine only. If you went the other way, because you happen to know what those are, you could say that looking at secant theta, I'm not going to give myself much room if I do it there, so let's put it down here. We would have 2 secant theta tangent theta plus secant squared theta. Those are the derivatives using secant and tangent. Now, is that equivalent to what we have here? Let's see, this would be cosine theta, and this would be sine theta cosine theta, and this would be 1 divided by cosine squared theta. Am I going to get the same thing? 2 sine theta divided by cosine squared theta plus 1 divided by cosine squared theta. Same thing? Add those together. Okay, so either way you want to work this, you'll get to the same answer. Now the question is, what's the next step? I take the derivative. What am I trying to do here? Find the critical numbers. Okay, so what's it mean to find the critical numbers? Brandon, help us out here. Okay, so you've got a choice. You can continue with secant if you wish, or you can use our cosine squared theta minus 2 sine squared theta divided by cosine squared theta. Setting it equal to 0, a fraction equal to 0. Which part of the fraction is the only part that could possibly give us a 0 value fraction? The numerator, yeah. If we multiply both sides by the denominator, we just get 0. So we have 0 equals cosine squared theta minus 2 sine squared theta. Now what? Let's see what happens if I continue using my secant information. Here I would have 0 equals, and I'm going to go back and pick this up right here. And I have a secant theta I can factor out. And that would leave me with 2 tangent theta minus, squeeze that in there, secant theta. Can you read that? I just said it, so hopefully go back on the video you can see that. If I have 2 factors and they equal 0, that helps me out, doesn't it? 2 factors equal to 0 tell me that one of the factors has a 0 value, so either secant theta is 0 or 2 tangent theta minus secant theta, I've got to write that better, is equal to 0. Yeah, Casey? Is it a plus there? Yeah, okay. So we have secant theta is 0 or 2 tangent theta plus secant theta is 0. How's that going to help us? Divide by cosine theta equals 0, so this would then be undefined. I agree. Okay, what about this one? let's see, that's 2 sine theta divided by cosine theta equals negative 1 divided by cosine theta. Can we do that? I have 2 fractions with the same denominator. If 2 fractions have the same denominator, then what must be true about their numerators? Do I need to pause this again? They must be equal. Okay, so we have 2 sine theta equals negative 1. It means that sine theta equals negative 1/2. What would theta equal? What kind of a triangle will give you sine of 1/2? What's the equivalent? How much? 45. So if these angles are equal, then I have this and this. I think this is the square root of 2. The sine would be 1 divided by the square root of 2. I don't think that's 1/2. So let's try 30, 60, 90. If this is my 60, this is 1. That must make this 2. Square root 3 with the sine of a 60 equal 1/2. Pardon? Yes? Okay. So that would be 60 degrees if you want to go into degrees here. If it's 60 degrees, but I want it to be negative 1/2, where's my terminal side? In the first quadrant? Or somewhere in the third and fourth, and which one is it? What do you think? My reference angle is 60, but I need sine to be negative 1/2. So I need to have something down here, right? I mean, remember each point on the unit circle is cosine sine. So sine would be negative in the third and fourth quadrants. Okay, so which quadrant is my terminal side in? 3 or 4? 3? If I do 3, then I'm looking at an angle like this, so that this is the same as 60 degrees. What kind of an angle is that? So if this is pi, let's see, what is equivalent to 60 degrees? What is it? Pi divided by 3? Is that what you're saying? Okay, some of you are saying, I'm not sure. So 60 is to 360, as radians is to 2 pi. So if you're not sure, we can always do this. 2 pi times 60 divided by 360. I think you're right. Pi divided by 3. Again, if you don't know these, you don't have to memorize this stuff. Just build yourself a proportion. So pi divided by 3. So if my reference angle is pi divided by 3, then what is this one? Oh, wait a minute. You've let me make a mistake here. What's the mistake? Why should it be 30? Because we're using what trig function? Wait a minute. We're using sine, right? Okay. So this would be cosine. So what we really need here is not 60, but 30 degrees. Okay. Does that change this at all? Okay. So it's pi divided by 6. Okay. So so let's see. This would be 30, and this would be 12. So pi divided by 6. Okay, so what is this angle all the way over here? So here it's pi, and then pi divided by 6, so theta must be Thank you. I need your responses, otherwise